Welcome, Shigeaki. It's a pleasure to have you here at the Max Imaging and Spatial Biology Days. To start with, could you briefly tell us a bit about your research focus and the main question that you're trying to address?
Yeah, I'm working in imaging facility in Karolinska Institutet, and I'm helping a facility user, and at the same time I'm doing research for the method development to accelerate the user's research field in general. But I'm working in imaging facility, so my focus is like a good 3D imaging, developing good 3D imaging method. That's the current focusing.
And why 3D imaging is so important? You made this very nice comparison between 2D workflows and 3D workflows. Could you elaborate a bit on that? And what are the advantages of 3D imaging?
Yeah, well, advantage is but actually very clear because we are living in 3D world, and then everything's happening in 3D. But technology research method is 2D is the major method to analyze, right? Then it's very difficult to capture all 3D information by doing 2D analysis. So one of the 3D imaging is a very game changer because this technique can allow us to image 3D as it is. So we can capture all the information. Yeah, that also allow us to take the information which was missed before in the analysis of the 2D.
Yeah, and what about the manual workload? Is 3D better than 2D going for sections versus imaging the entire sample at once?
Yeah, like I think everyone imagines that 3D workflow may be laborious, but actually it's opposite, I think, because in case of the 3D, if you cut many sections, it's a lot of work actually, but we can skip that cutting in 3D imaging methods. And also light speed microscope, it's highly automated recently. For example, Blaze system, it's really easy to use and very fast. So I think it's work amount is not so, but in total work amount is not so different, I think.
So going a little bit through your journey, through your career, and I'm thinking precisely about the DIPCO paper, there you really showed quantitatively what would be the advantage for a pathologist to move into a 3D workflow compared to the classic pathology workflow of cutting the sample and creating slides and evaluating and making diagnoses and decisions based on that.
Yeah.
Could you describe us a bit more?
Yeah. In the hospital, usually FFPE sample is used to diagnose cancer tumor tissue. Then, but usually, pathologists just use one or two large section to conclude the grade or stage. Yeah, but that way, of course, tumor is really large tissue, and then if you just see the one section, then pathologist can miss a lot of information actually. So idea to scan whole tumor in 3D is like a natural idea to understand the malignancy of the tumor without losing the information. So to do that, pathologists can become confident about their diagnostics more, and give patient more accurate information about their tumor. So that's I think 3D imaging is really useful to find to get the comprehensive information. For example, I think mainly malignancy is the main point. 3D imaging can capture.
Yeah, and what do you think is missing, or how long will it take for pathologists to move completely into 3D workflows and have them as the new gold standard? Because at the research level, it's not rocket science anymore, I would say. There's a lot of researchers who now moved completely into 3D, but at the pathology level, we are still very much 2D focused.
Yeah, that's a good question. Yeah, no. So 3D imaging shows a promising result already, but however, it takes time to prepare sample, and also before it took time to image sample as well. But for now, light switch system is very well established. Like a Blaze system, it's just take I think 10 minutes to scan. So that part is already solved, but still we have a time issue for sample preparation. So that 1 week or 2 weeks, it's for the hospital, it's too long to incorporate 3D technique routinely. So, but that is the case that we stain antibody. We stain tissue with antibody. So I think 3D imaging will be incorporated, just a chemical dye or something. Then I think it's sufficient. I think for now it's already enough to use 3D imaging. But of course, current diagnostic is based on huge amount of the 2D section. Right, so we need accumulation of the data in 3D imaging. So, but it will gradually happen. Yeah, I think about the transition from 2D to 3D.
Yeah, I agree with that. You mentioned 3D reagents and sample preparation, which is very essential when talking about light sheet microscopy. Yeah. How important is it for you to have an established protocol, tested and working antibodies? Yeah. What's your experience on that?
Yeah, that's very important because tissue clearing takes very long time to prepare sample. Then if you couldn't get the result, then it's a kind of disaster. Right? So if method is validated, the antibody is validated, confirmed to penetrate well inside of the tissue, but those kind of validation is necessary for 3D imaging. And that's especially because of the time. You cannot test easily, unfortunately, because one experiment takes 2 weeks, or some experiment takes 1 month. Then, so it's so if researcher rely on the validated kit, it's really nice things.
Yeah. Now, going back and to move on with your career, TRISCO, obviously outstanding publication allowing to image RNA on large samples as large as a whole mouse or rat brain. Can you tell us a little bit about the story and what does this new technique, this new protocol open up for? What kind of discoveries can be now made that would not be possible before?
Yeah. So the reason why we try to develop a TRISCO method is we found that the RNA imaging method is not so reproducible. And also, we found that it's actually challenging. Now, recently, single-cell RNA sequencing is very common. So many researchers want to detect RNA in the tissue. So that's why we try to develop a TRISCO method, and then we take care of the reproducibility and protocol robustness. So for this, for now already many researchers using TRISCO method, and then of course, RNA is a good target, so everybody is happy to detect many their interest of RNA molecules. That's good, and then I think whole brain imaging will be accelerated. So that's one thing. But we noticed that we kind of broke the limitation of the sample size in this method. So we can now stay in rat sample or guinea pig sample, and then result looks very uniform. So we open up the door to use very large animal model for the researches. For example, now many researchers use mouse model for the behavior analysis, but some behavior that is advantageous. But researcher couldn't analyze the rat brain in the whole brain scale. But now it's possible.
Yeah.
So I think this is to me big surprise, but we open up the door for the handling the large animal model. Then I think many fields related to those large animal model will be accelerated, I think. Research of the.
Yeah, excellent. Yeah. And thank you very much for opening that door. Follow-up question, how does the future look like? Transcriptomics itself is already a big field, but it's mostly done on slices or on very small stacks. Yeah. Do you think that in the future we will entirely move into large samples?
Yes, that's actually happening already. For example, in this year already, some of the research show the capability of the multi-round imaging, multi-round RNA imaging in the large tissue. Then, but it's kind of already achieved that like a 10 to 20 molecule is the already target of the molecule range. Not like a special transcriptomics on 2D, it's 1,000 or 10,000. That level, it's maybe takes time. But like a 20 to 50, that's the like a practical like a range of the number, practical range of the target molecules. That will be soon achieved, I think.
Wow, yeah, looking forward to that. Yeah. Now, let's focus a bit on the microscope itself. Yeah. 2 questions. Why is light sheet important and necessary for 3D imaging of large samples? What are the advantages of doing light sheet microscopy? And why the UltraMicroscope Blaze specifically? What are the aspects that you like the most about our instrument?
Yeah. So I think light sheet microscope is a really good tool to scan like an intact tissue from a small to large sample. Then we can get a very clear image, and usually it's automated. So actually to see the 3D structure of tissue, it's I think default standard must equipment we need to have, right? Then I think so about the Blaze, I think Blaze is really stable system and user friendly, but speed is wonderful actually. It's very rapid. Mouse brain scan mouse brain scan finish in 10 minutes. So that's amazing. Yeah, really game changer. Yeah. So I'm managing the Blaze system already. Then I think all users really happy about using the Blaze system.
That's fantastic.
Yeah, that's fantastic. I think that's because of the total capability. I think that means speed, robustness, user friendliness. Yeah. So yeah, Blaze is a really wonderful system. So I think everyone, I want everyone to use Blaze.
Thank you. Yeah, let's have as many users as possible. Thank you very much once again, Shigeaki, for your time. It was a pleasure to have you here.
Thank you very much.